In this very lesson, we shall be looking at combinatorial numbers, also known as combination numbers or combination. Combination will be discussed details under the topic probability, but here in binomial theory, we are just going to look at the evaluation of it, just the evaluation of combination numbers. And combination R is written as combination R, which is the same as n combination R. Now, by definition, n combination R is given as n factorial all over n minus R, all factorial, then we have R factorial. So when you have, let's say, 3 combination 2, which is the same as 3 combination 2, by definition, we know that our n is equal to 3, our R is equal to 2. So we are just going to substitute these numbers in place of that. So we have 3 factorial all over 3 minus R, which is 2, all factorial, multiplying what? 2 factorial. Another example, if you have, let's say, 5 combination 3, we know that our n is equal to 5, our R is equal to 3. And by definition, we are going to have 5 factorial all over 5 minus 3 all factorial, and then we have 3 factorial. Let's look at the last example. So let's take it that you have 7 combination 5. We know that our n is equal to 7, our R is equal to 5. And by definition, 7 combination 5, we are going to have 7 factorial all over 7 minus 5 all factorial, and then we have 5 factorial. Now that we know this, how do we evaluate them? So let's look at the evaluation of these combination numbers. So let's take examples. So we have these 4 examples. We are going to go through them one after the other. So we have the first example. We are to evaluate 8 combination 3. And we know that by definition, combination n combination R is given as n factorial all over n minus R all factorial multiplying R factorial. So with this, we are going to have 8 combination 3 is equal to, our n is equal to 8, our R is equal to 3. So we are going to have 8 factorial all over 8 minus 3 all factorial multiplying 3 factorial. So we have this 8 factorial all over 8 minus 3 factorial multiplying 3 factorial. Somebody may ask, what is factorial? Please, we have already discussed this in our previous lesson. So 8 factorial means we are going to multiply the number 8 and all those natural numbers that are lesser or smaller than 8. So let's continue. So we have 8 factorial all over 8 minus 3 will give us 5 factorial multiplying what? 3 factorial. Now we know that 8 factorial means we are going to write the number 8 and all those natural numbers that are smaller than 8. We are going to multiply them. So this is what 8 factorial. Since we have 5 factorial here, we can end at this. So we can write this, the whole of this, as 8 times 7 times 6 times 5 factorial. Because 5 factorial will cater for all those natural numbers behind 5. So we can shorten this and write it as that. So in place of this, we are going to write that. So we are going to have 8 times 7 times 6 times 5 all factorial all over 5 factorial multiplying 3 factorial. So we have 5 factorial here. It will cancel this 5 factorial. So we are left with 8 times 7 times 6 all over 3 factorial. 3 factorial means 3 times 2 times 1. So in place of that, we can write this 3 times 2 times 1. So we have 8 times 7 times 6. This will give us 6. So you can see that this 6 will cancel this 6. We are left with what? 8 times 7, which will give us what? 56. 56. Therefore, 8 combination 3 is what? 56. Let's take the next example. So we have 10 combination 2. So we know that our n is equal to 10, our r is equal to what? 2. So by definition, 10 combination 2 will give us 10 factorial all over 10 minus 2 all factorial multiplying 2 factorial. So we have 10 factorial, 10 minus 2 give us 8 factorial multiplying 2 factorial. Now since we have 8 factorial here, 10 factorial, which is 10 times 9 times 8 times 7 times 6 and so on up to 1, we can shorten it to 8 factorial. So in place of 10 factorial, we can write this. So we have 10 times 9 times 8 all factorial over 8 factorial multiplying what? 2 factorial. Now we have 8 factorial, 8 factorial. So this and that will cancel. We are having 2 factorial. So we have 10 times 9. 2 factorial means 2 times 1. So when you simplify, you know that 2 can cancel 10 and we have 5. So 5 times 9 will give us 45. Therefore, 10 combination 2 will give you 45. Let's take the next example. So we have 5 combination 2. We know that our n is equal to 5. Our r is equal to 2. Therefore, 5 combination 2, by definition, we are going to have 5 all over 5 minus 2 all combination multiplying 2 combination. So we have 5 factorial all over 5 minus 2 give us 3 factorial, and then we have 2 factorial. Now you know that 5 factorial can be written as 5 times 4 times 3 factorial. Since we have 3 factorial here, let's end it here. So in place of that, we are going to write 5 times 4 times 3 factorial all over 3 factorial multiplying 2 factorial. So at this very point, 3 factorial cancel 3 factorial. We are left with 5 multiplying 4 all over 2 factorial, which is the same as 2 times 1. You realize that 2 can cancel 4, we have 2. So at the end, we have 5 times 2, that gives us 10. Therefore, 5 combination 2 will give us 10. Let's take the last example. So we have 4 combination 3. From this, our n is equal to 4. Our r is equal to 3. Therefore, 4 combination 3 is equal to 4 factorial all over what? 4 minus 3 all factorial multiplying 3 factorial. We have 4 factorial all over 4 minus 1. 4 minus 3 will give us 1 factorial multiplying 3 factorial. And we know that 4 factorial is the same as 4 times 3 times 2 times 1. Now you realize that we have 3 factorial here. So we can end it at 3 factorial. Because 3 factorial will cater for all those natural numbers that are lesser than this. So in place of 4 factorial, we are going to write this. So we have 4 times 3 factorial all over 1 factorial multiplying 3 factorial. So you realize that this will cancel this. So we have 4 all over 1 factorial, which is the same as 1, and that gives us what? 4. Very, very easy and then simple. So we are moving on to equations involving combinations. Equations involving combinations. And we will be looking at these 3 questions. So let's start with the first one. So we have our first example. N plus 1 combination 2 is equal to 21. We have to find the value for n. And the n that we are looking for, it should be what? A natural number. We know that by definition, n combination r is given as n factorial all over n minus r all factorial multiplying r factorial. So in the question, our n is equal to n plus 1, and then our r is equal to 2. So we are just going to substitute these values in place of the formula. So we are going to have n plus 1 all factorial all over n plus 1 minus r is what? 2 all factorial. Our r is what? Still 2 factorial, and this is equal to 21. Now remember that in our previous lesson under the factorial, we said that when you have 7 multiplying or 7 times 6 factorial is the same as what? 7 factorial. Therefore, when you have n plus 1, n factorial is the same as n plus 1 factorial. So it means that in place of this, we are going to write what's this. I believe you are following. Good. So we have n plus 1, n factorial. When you do the algebra, you are going to get n minus 1 factorial 2 factorial, and this is equal to 21. Now we know that from factorial in our previous lesson, n factorial is the same as n minus 1, n minus 2, and so on. Since we are having n minus 1 factorial, we can end at n minus 1. So n factorial is going to be n minus 1 all factorial. This is the same as that. Because we are having n minus 1 factorial here, we can end here so that this will cancel that. That's the reason why we are ending at this very point. So we have n plus 1. This is the same as that. So we have n n minus 1 factorial all over n minus 1 factorial 2 factorial, and this all is equal to 21. So you realize that this will cancel this. So we are going to be left with n plus 1 n all over 2 factorial, which is equal to 21. So from here we know that 2 factorial is the same as 2 times 1, and 2 times 1 is still 2, so we can write it as 2. Now from this we can do some cross multiplication, so this will multiply that, this will multiply that. So we are going to have n plus 1, and then 2 times 21 will give us what? 42. Let's expand the brackets. This will give us n squared plus what? N, and this is equal to 42. Now, why don't we bring the 42 to the left hand side of the equation and then see something? So we have n squared plus n minus 42 is equal to 0. What do you see? You see that we are getting what? A quadratic equation. Quadratic equation. And solving questions on quadratic equation, we can use the factorization, computing the squares, the almighty formula, or the quadratic formula. So let's use the factorization. So we are going to look for two numbers that when we multiply, we are going to get 42. That when we sum, we are going to get positive 1. And those numbers are 6 and then what? 7. So we have minus 6 and then positive 7. This will give us negative 42. When we sum them, we are getting 1. So let's substitute this in place of that. So we have n squared minus 6n plus 7n minus 42 is equal to 0. Let's do some factorization. We have n here, n will come out, we are left with what? N minus 6. We have 7 and 7 to 42, we have 6. And this is equal to 0. So we can pick those outside the bracket. We have n plus 7 n minus 6 is equal to 0. So we are going to have n plus 7 is equal to 0, n minus 6 is equal to 0. Our n is equal to minus 7, or n is equal to positive 6. Since the range that was given is that n must be a natural number, n must come from what? Natural numbers. So when we look at this, negative 7 is not a natural number. Therefore, our n is equal to 6. As easy as ABC. Let's take the next example. So we have the last example. You can try your hands with me. So we have n combination 2, which is equal to 6. We have to find the value for n, and that n might be a natural number. So from this, our n is equal to n is equal to n, and r is equal to 2. So we are just going to substitute this in the formula. So we have n factorial all over n minus 2 factorial 2 factorial, and this is equal to 66. Now we have already established that n factorial is equal to n minus 1, n minus 2, and so on. Since we have n minus 2 factorial here, we want to cancel the factorial from it, so we can end at this 0 point. So in place of n factorial, we are going to substitute that. So we have n minus 1, n minus 2 factorial all over this n minus 2 factorial 2 factorial, and this is equal to 66. So realize that we have n minus 2 factorial, n minus 2 factorial. This will cancel this. So we are left with n minus 1 all over 2 factorial, and 2 factorial is the same as 2, which is equal to 66. So from here, we can do some cross multiplication. So we have n minus 1 is equal to 2 times 66 will give us 132. So from here, we can expand the bracket. We have n squared minus n is equal to 132. Let's bring 132 to the left hand side. We have n squared minus n minus what? 132, which is equal to 0. We have what? A quadratic equation. So we are going to look for two numbers that when we multiply, we are going to get 122. When we sum them, we get negative what? 1. And those numbers are 11 and then minus 12. When we multiply this, we are going to get that. When we sum them, we are getting this. So we are just going to substitute this in place of the n. So we have n squared minus 11n, plus 11n minus 12n minus 132. Factorization. We factor n out, we are left with what? N plus, this will give us 11. And then we have minus 12, we have n plus what? 11. And this is equal to 0. Taking those outside the bracket, we have n minus 12, n plus what? 11. And this gives us 0. So we have our n minus 12 is equal to 0, n plus 11 is equal to 0. Our n is equal to 12, or n is equal to minus 11. Now the question says that n must come from what? The set of natural numbers. This is not a natural number. Therefore, our n that satisfies this question is equal to 12. I'm going to give you some try questions. Pause the video, you try your hands on it. So this is your question. See you tomorrow. Bye bye.